So on to the fourth part of this chapter, which is about use integration. We learnt earlier that if you have displacement and you differentiate it, you get velocity. If you differentiate it again, you get acceleration. So if you differentiate s, displacement, with respect to time, you get velocity. If you differentiate velocity with respect to time, you get acceleration. Equally, if you differentiate displacement twice, you again get acceleration. Well, as you know, integration is the opposite to differentiation. So if you take acceleration and you integrate it, you get velocity. So velocity is the integral of a with respect to time. If you integrate velocity, you get back to displacement. So displacement is also equal to the integral of velocity with respect to time. So let's now use this in the next example, which is example 6. Example 6 says that we have a particle moving on the x-axis at time t equals 0. The particle is the point where x equals 5. And t equals 0, x equals 5. And the velocity of the particle is given by 6t minus t squared. I need to find an expression for displacement and then the distance from the starting point when t equals 6. So if I've got velocity and I want to go to displacement, I need to integrate. So you need to remember this order: s, v, a, v, s. So differentiate to go from s to v to a, integrate to go from a to v to s. You're going to have to remember that, no way around it. So s is the integral of v with respect to time. Now remember, when you integrate, you raise the power and divide by the new power. So that's going to be 6t squared over 2 minus t cubed over 3 plus the constant of integration. So let's just tidy that up a little bit. So that's 3t squared minus a third t cubed plus c. Now remember also in the question we're told when t equals 0, x equals 5. XS, same thing here. So when t equals 0, the displacement is 5. 0 minus 0 plus c, therefore c equals 5. So our complete equation is s equals 3t squared minus a third t cubed plus 5. And then when t equals 6, the displacement from the starting point is going to be 3 times 36 minus a third of 6 cubed plus 5. So just smash that in the calculator. So I've got 3 times 36 minus 6 cubed divided by 3 plus 5 equals 41 metres. But we wanted, remember, that's the displacement from the starting point, but when t equals, now that's the displacement from the origin, but when t equals 0, it was already 5 metres away. So if we take that 5 metres off, it's going to be 36 metres from the starting point. Okay, on to example 7. Which says a particle travels in a straight line. After t seconds, its velocity is given by v equals 5 minus 3t squared. Find the distance travelled by the particle in its third second of motion. Okay, so what we're going to need to do here is first work out an equation for its distance. So that's going to be the velocity integrated. So any number goes to that number t, and then we raise power and divide by the new power. So those are going to cancel, plus the constant of integration. However, what we want here is the distance travelled in the third second of motion. So between 0 and 1 second is the first second of motion, between 1 and 2 seconds is the second of motion, between 2 and 3 is the third second of motion. So what we can do now is apply some limits to the integration, which negates the need to work out the constant of integration. So we're just going to work out what the value of s is between 2 and 3. So that's 5t minus t cubed between 3 and 2. So we substitute in 3, we get 15 minus 27. Substitute in 2, we get 10 minus 8, and then we obviously need to subtract them. So that's going to be minus 12 minus 2, which is minus 14 metres. So that just means you're going to be 14 metres to the left. You've travelled 14 metres to the left of to the left. So the negative value here just means you'll be going against the original direction. So it was travelling in this direction, and then between 2 and 3 seconds it travelled 14 metres in this direction. Okay, that completes all the examples prior to exercise 11D, so have a go at those now.